Hello students, welcome to my channel. In today's video, we are going to learn the integration by the method of substitution. Make sure this is a very useful method of integration. The first problem what we are going to solve by this method of substitution is integration dx by within bracket 1 plus x square into root over tan inverse x plus 4. Okay. So let's see how to solve this problem by this method. Look students, if we consider tan inverse x plus 4 in terms of some other variable, then we are going to get such a simple structure which will help us to integrate this expression. So let's do this. Let tan inverse x plus 4 is equals to suppose t. Okay. So differentiating both sides with respect to x, we get 1 by 1 plus x square. We know ddx of tan inverse x means 1 by 1 plus x square, and this will give us 0. This is equals to dt by dx, right? So look student, this can be written as dx by 1 plus x square is equals to dt, and hence this particular expression can be substituted in terms of dt. So here we get dt by root over t, because root tan inverse x plus 4 is taken as t, so it will be root over t. So this can be written as t to the power minus half dt, right? So this will be t to the power half plus 1 by half after integration, and there will be the constant of integration which will be added to this result. So this will give us 2 root t plus c, right? Now look students, we had to find the integration in terms of x with respect to x, but it is in terms of t. So obviously finally in this case we must replace this t with the given expression. So here putting t equals to tan inverse x plus 4, we get 2 root over tan inverse x plus 4 plus c, and hence the result of integration is obtained so easily by using the method of substitution. Now I have taken another very important problem, integration root over a plus x by a minus x dx. So here we have to solve this problem by the method of substitution, and this expression will be solved by a very simple substitution, that is x equals to a cos 2 theta. So let's see how does this substitution help us. Let x equals to a cos 2 theta, right? So now we have to differentiate both sides with respect to x. So differentiating both sides with respect to x, we get 1 is equals to minus a sine 2 theta into 2, because this 2 theta will be differentiated and hence 2 will be found, and it will be d theta by dx. So here we can write dx equals to minus 2a sine 2 theta d theta. So now here this dx can be replaced by this expression. So let's do this. This will give us integration root over a plus a cos 2 theta by a minus a cos 2 theta into minus 2a sine 2 theta d theta, right? So here this is minus 2a integration, all these a's will be cancelled after taking common in numerator and denominator. So it will give us root over 1 plus cos 2 theta, which can be written as 2 cos square theta, and hence 1 minus cos 2 theta will give us 2 sine square theta, right? And here it is sine 2 theta, which can be written as 2 sine theta cos theta, and hence it will be d theta. So now in the next step, we can write minus 2a, all these 2's will be cancelled, and hence we will get cos theta by sine theta after finding the square root into this 2 can be written over here. So it will simply be sine theta cos theta d theta. Now look students, this sine theta can be cancelled and hence we get minus 4a cos squared theta d theta. Now, if we consider a 2 from this 4, from the factors of 4, then we will get minus 2a 2 cos squared theta d theta, right? Now, this 2 cos squared theta d theta can be replaced by cos 2 theta plus 1 because we know that cos 2 theta is equals to 2 cos squared theta minus 1. So, in the place of 2 cos squared theta, we can write cos 2 theta plus 1 d theta. Okay. Now we have got a very simple structure. Now we have to find the integration of this. So it will give us 2a cos 2 theta d theta will give us sine 2 theta by 2, right? So let's write this sine 2 theta by 2, okay? And plus 1, this d theta means integration d theta 1 means will give us theta and hence the constant of integration should be added to it. So we have found that integration root over a plus x by a minus x dx is equals to minus 2a within bracket sine 2 theta by 2 plus theta plus constant of integration as usual by substituting x equals to a cos 2 theta, right? Now look students, this can be written as minus a. We are multiplying this 2 inside the bracket with the terms inside the bracket. So this will give us sine 2 theta plus 2 theta, right? Plus c. Now here we had to find out the integration with respect to x. But here the result has come out in terms of theta. So we have to substitute this, right? So here look students, x equals to a cos 2 theta. Let's see how to do this substitution. So clearly cos 2 theta is equals to x by a. So cos square 2 theta is equals to x square by a square. In the place of cos square 2 theta, we can write 1 minus sine square 2 theta is equals to x square by a square. Okay. So from this we can get sine square 2 theta is equals to 1 minus x square by a square, which will be a square minus x square by a square. So this is sine square 2 theta, but we need sine 2 theta. So we have to find out the square root to both sides. So sine 2 theta will be equals to root over a square minus x square by a, and hence sine 2 theta is represented in terms of x. And we get that cos 2 theta is equals to x by a from our substitution. So theta is equals to half cos inverse x by a, right? So here this theta and this sine 2x will be replaced in terms of x. So let's do this. So finally we get integration a plus x by a minus x dx is equals to minus a within bracket sine 2 theta means root over a square minus x square by a plus 2 theta means this theta will be represented in terms of this, and hence it is 2 theta means it will be simply cos inverse x by a, because 2 into half will be cancelled and hence it is cos inverse x by a plus the constant of integration, and hence we have found the result of integration so easily by this substitution. Now we are going to find integration dx by within bracket x minus p into root over within bracket x minus p into within bracket x minus q. This particular problem will be solved by the method of substitution very easily by a very unique transformation. So let's see. Let x equals to p sec square theta minus q tan square theta. So here differentiating both sides with respect to x, we get 1 is equals to 2p sec theta into sec theta tan theta. So as a whole it will give us sec square theta tan theta, and this will give us 2q tan theta sec square theta d theta dx, right? So this will simply give us dx is equals to 2p minus 2q sec square theta tan theta d theta. That means in the place of this dx, we can transform this particular expression. So let's do this. Integration 2p minus 2q sec square theta tan theta d theta by x minus p, means this particular expression minus p. So just think, students, when p will be taken in common, when we are substituting x in terms of this particular expression, then we are going to get p into sec square theta minus 1, which will give us p into tan square theta minus q tan square theta is there, right? Root over x minus p will give us the same thing, that is p minus q into tan square theta. And when this x will be substituted by this expression, then after taking q in common, we are going to get 1 plus tan square theta, means p sec square theta minus q sec square theta, right? So this will give us 2 into p minus q integration sec square theta tan theta d theta by tan square theta can be taken in common, so it will be p minus q into tan square theta, and here it will give us root over p minus q into root over p minus q, means another p minus q into tan theta into sec theta, right, students? So here now we can simplify this expression very easily. Tan theta will be cancelled, 1 sec theta will be cancelled, and hence in the numerator portion we are going to get 2 into p minus q, and this p minus q into p minus q, that is p minus q square, will be taken in common, will come out of the integration sign, and hence in the numerator we will get sec theta d theta, and in denominator we are getting tan square theta, and hence we have got a very simple expression to be integrated. So let's see how to find the integration. So we have got integration dx by x minus p within bracket root over within bracket x minus p into within bracket x minus q is equals to 2 into within bracket p minus q by p minus q whole square integration sec theta by tan square theta d theta by this particular substitution. X equals to p sec square theta minus q tan square theta. Now here we get by p minus q, right? And here within integration sign we find 1 by cos theta into cos square theta by sin square theta. That is, here sec theta has been written as 1 by cos theta and tan square theta is written as sin square theta by cos square theta. As it is divided, so that's why after multiplication sign it has been reversed. So here we find cos theta by sin square theta. So this can be written as 2 by p minus q integration cos theta by sin theta means cot theta into 1 by sin theta, because in denominator we have sin square theta. So 1 by sin theta is there, which can be written as cosec theta d theta, and hence integration cot theta cosec theta will give us minus cosec theta plus the constant of integration, and hence integration cot theta cosec theta d theta is found, which is minus 2 by p minus q cosec theta plus c, because 2 by p minus q was there. Okay. Now we have to replace this cosec theta in terms of x. So now let's see how to do this. So after integration we have found minus 2 by p minus q into cosec theta plus c plus constant of integration. Now look students, we have x equals to p sec squared theta minus q tan squared theta, right? So from this we have to represent this cosec theta in terms of x. So here we get x minus p is equals to p sec squared theta minus q tan squared theta minus p. Now if we take p in common, then we are going to get x sec squared theta minus 1, right? P into sec squared theta minus 1, and that can be written as tan squared theta. So p into tan squared theta minus q into tan squared theta. So x minus p is equals to p minus q into tan squared theta. That means tan squared theta is equal to x minus p by p minus q. Now from this tan squared theta, we have to obtain cosec theta. How? We know 1 by cot squared theta equals to tan squared theta. So here we find cot squared theta is equals to p minus q by x minus p. It will also be reversed. Okay. So here this cot squared theta can be written as cosec squared theta minus 1. This is equals to p minus q by x minus p. And hence this 1 minus 1 can be shifted to the right hand side of the equal sign. So cosec squared theta becomes p minus q by x minus p plus 1, and hence after simplification we will find x minus q by x minus p. So this will give us x minus q by x minus p after simplification. So what is cosec theta? This is root over x minus q by x minus p, right? So cosec theta is represented in terms of x, and hence this can be put over here. So here we find integration dx by x minus p into root over x minus p into x minus q is equals to minus 2 by p minus q into cosec theta, means into root over x minus q by x minus p plus c, means constant of integration, and hence the result is found.